Lesson 7.3, Video 3. Trig ratios for special right triangles. So now we're going to look at some special triangles and see if there's any patterns we notice. What kind of triangle is HJK? Well, if you notice, you have two congruent sides, so this would be considered a right isosceles triangle. What's the measure of J then? Well, if it's a 180 degrees total for all angles, and you have one angle that's 90, you have, for isosceles triangles, these two base angles are equal in measure. So if they are the same, then you only have one option, and that is 45 degrees. Okay, so what is tangent J then? If you're looking from J, this side is considered opposite. This is adjacent. Remember, your longest side is your hypotenuse. So tangent J, meaning I'm looking from angle J, is opposite over adjacent, and you get 1. So just an observation, and we'll look at that in more detail in a moment. Here's a new one. What is sine C? Again, we're looking from this angle. So we have opposite, we have adjacent, and the longest side is hypotenuse. So sine C is opposite, so 12 over hypotenuse, which is 24, so 1/2. This is the exact values. So let's look at, we've been doing it, but you haven't noticed yet, but we talked about an isosceles right triangle, which is a 45, 45, 90 triangle. And if you remember the special right triangle rules, you had a quick way to do Pythagorean theorem on these, where you had, if you said unit lengths of 1 and 1, the hypotenuse would be √2. And you can use Pythagorean theorem to prove that. And we did this with similar triangles, if you remember back in quarter 1, I believe. 30, 60, 90 triangle. This one looks a little more confusing, but if you clean it up, and there's your right angle, right there. Your hypotenuse is 2. Your height of that is √3. And your base, since your whole thing is 2, then your base for half of this is 1. So basically a 30, 60, 90 triangle is half of an equilateral triangle. So again, you see your relationship here, and for record here, this would be considered a 60-degree angle, and this would be the 30-degree angle. So what does that mean with trig? Well, if you use these two triangles, this one and this one, and do trig, meaning sine, cosine, tangent, you have certain angles that show up here. Again, this is it's a isosceles right triangle, so this is 45, and so is this. So you have 45 degrees showing up. You have a 30 degree and a 60 degree angle show up. So that's represented here. So with these particular angles in mind, if you did sine of 30 is 1/2, right here. Cosine of 30 is √3/2, and tangent of 30 is √3/3. Now if you actually did the calculation for tangent 30 up here, tangent of 30 would give you opposite over adjacent, and we learned we can't have that. We would have to rationalize, which we've done before, and that would give us √3/3, and that's why you have √3/3 in there. They actually did the rationalizing for you. 45, sine of 45, 1/√2. Now there they didn't do it. 1/√2 is not rationalized, so we must do so and we get root 2 over 2. So this is better written as root 2 over 2. And the rest of them is simplified and rationalized. So these are exact values for these trig functions at those degrees. These degrees will be expected to be understood and memorized in Algebra 2 trig, as well as 90 degrees, 180, 270, and 360. But you'll have plenty of time to work on that. And this ends Lesson 7.3, Video 3.